Assalamualaikum. Let's talk about pure bending. Let's refer to our friend, the Wikipedia. Pure bending is a condition of stress where bending moment is applied to a beam without the simultaneous presence of axial, shear, or torsional forces. Pure bending occurs only under a constant bending moment since the shear force, which is equal to delta M.
Nah, bending is complex like that. It's actually when a structure is applied under a load, it's deformed, just like this. Okay, let's take a look how it works.
This is pure bending.
As you can see in this image of Wasil lifting the weight, both the weights on the bar are creating an opposite but equal bending moment acting downwards and towards Wasil's hands. This will cause the bar to bend in the middle. You probably cannot see it because the formation is really quite small. Here's an extreme example of a bending test on a Boeing 777 wing.
153, 153.
While a structure of multiple bodies, like the Boeing 777 wing, becomes completely destroyed during a huge bending stress, on a smaller scale, the deformation when a bending force acting on a single straight prismatic material will not be as dramatic. The bending moment will cause the material within the bottom portion of the bar to stretch and the material within the top portion to compress. Consequently, between these two regions, there must be a surface called the neutral surface, in which the longitudinal fiber of material will not undergo a change in length.
Okay, different material react differently even the force applied is the same. For example, it's the wood branch. It's the easiest to bend with the same load compared to the aluminium. It's harder. So different material has a different resistance towards bending. This is important in engineering application. Okay, for the application, let's go to the hanger. Of the aircraft, which is Cessna 150. Okay, let's take a look. Okay, the first one we choose that tend to bending is the wing.
Wing on an aircraft will undergo a lot of bending throughout its lifetime. The wing will bend upwards during flight and bends downward while on the ground. This becomes a concern in aircraft maintenance due to the fact that the repeated stress will eventually cause a structural failure. Thus, it is important for aircraft engineers to design a wing that can withstand the repeating stress. It is common for aircraft wings to be designed long and flexible to compensate all the bending stresses with the right material to allow it to do so. Let's see a clip that clearly shows how much bend a wing withstands during flight and on the ground. The same can be said about landing gear, especially the fixed-up landing gear that are used on this aircraft, which is used to support the whole load of the aircraft while it is on the ground. The only improvement to the landing gear is the use of material that can withstand repeated bending stress better than steel that are currently commonly used. This is because adding additional structures to the landing gear will only add unnecessary weight to the aircraft, and this is highly unacceptable.
Thanks for watching. Lagi? Sekali lagi.